Hi everyone. Next we are moving to the photoelectric devices. Okay, this is the last video from the unit 6 energy sources. With that we completed the energy sources. So here photoelectric devices. Photoelectric devices means the device, here see, the device which converts light energy directly into electrical energy. That means those devices which converts light energy to electrical energy, those devices here call it as a photoelectric devices. Those devices here call it as a photoelectric devices. So here we'll consider two types of semiconductor devices here. Those devices, because why are considered two devices? Because self-generating. Those devices are photovoltaic cell and solar cell. Here two semiconductor devices. Those are self-generating photovoltaic cell as well as solar cell. Okay, so let us discuss the first one, photovoltaic cell. So the photovoltaic cell here, by look at this particular diagram, one metal connected to semiconductor. Okay, semiconductor. So in this photovoltaic cell, in this cell, light energy is used to create the potential difference, which is directly proportional to the frequency intensity of light. So whenever light fall on this particular semiconductor devices, what will happen? So potential difference will be occur. How the potential difference will be occurs here? So it consists of a piece of semiconductor, as well as that is a maybe this semiconductor may be germanium or silicon or selenium. These are the semiconductor we are using. So now here, whenever light fall on the semiconductor, what will happen? Valency electrons and holes are liberated from the crystal structure. So whenever light fall on this particular metal semiconductor, so the semiconductor valence electrons and holes are liberated. Whenever this is liberated means that emitted. So whenever it is liberated, what will happen? These electrons flow out of the semiconductor, okay, into the metal, whereas the holes flows in the opposite direction. So here, whenever holes flows in opposite direction, it creates the potential difference between the semiconductor as well as metal. So this metal and semiconductor potential difference is created. Whenever potential difference is created, definitely current will be flowing. So which sufficient to cause the flow of current through the load. This particular load, current will be flowing. Okay, this is the way the photovoltaic cell is working. Okay, now these cells are used in the devices like portable exposure meters and direct reading illumination, etc. So next we are moving to the solar cell. The solar cell, it is also called as a solar energy converter. That means solar, that is a sunlight energy, is converted into this particular sunlight energy is converted into electrical energy. Okay, that's why it is a solar energy converter. It is basically, it is a PN junction device, right? Solar cell is a basically PN junction device which converts solar energy into electrical energy. So look at here. In this particular structure, we may one glass is there. In that glass, after that your metal as well as P and N junction, lower it is a metal contact. So in between we have a junction. Okay, in this particular structure, this is a PN junction, this is a solar cell structure. Look at the construction and working now. It consists of a silicon PN junction diode generally packed in TO type. Okay, this total N-type. That means what we TO type, it is glass window on top. It is like a window, glass window to focusing, to observe the total entire light energy and focusing, and it is what we call total entire sunlight focusing on this glass. After that it is reached to the P and N junction. Now whenever surface layer P material made extremely thin, this particular P layer extremely thin, So that instant of light photons may be easily reached to the p-n junction. Whenever it is a thin, that means majority charge carriers of holes are more. Whenever it is a more, whenever light falls, it is easily reached to the particular junction, this particular p-n junction. Okay, so that's why p type material is a very thin. Coming to the next, whenever protons will be collide with the electrons, they impact the sufficient energy as to they leave the parent atom. That means whenever these protons are trying to cross the junction, valence electrons, it is collide, then it is gained some energy to overcome this barrier, that is a junction. So in this way, free electrons and holes are generated in the both the sides of junction. Their flow consists of minority current, very very important. It consists of minority current. This current is directly proportional to what? Illumination. Illumination is nothing but light intensity, that is a units are lumen per meter. Okay, and also it is depending upon the size of the surface being illuminated. For example, you are using large area, we can generate the more amount of energy based on the light intensity. Surface area can decide the how much energy you are generated. So now the open circuit voltage V is function of illumination. Consequently, open circuit voltage VOC. Consequently, the power output of solar cell depends upon the level of sun illumination. Just now I mentioned. So power cells are also available in the flash strip, so that cover the sufficient energy in the large surface area. So now at the last, nickel plated ring. So see here, nickel plated ring. This is a nickel plated ring. Here call it as a anode, positive, and a metal contact, it is a negative, it is connected in the bottom. That's what here. Okay, the nickel plated ring p-type layer acts as a positive output terminal, that is a anode, and the metal contact at the bottom serves as a negative output terminal, that is a cathode. Okay, so silicon and germanium mostly widely used semiconductor, for the solar cell. Nowadays we are using gallium arsenide, indium arsenide as cadmium arsenide also being used nowadays. Previously we are using silicon and germanium. Nowadays you are gallium arsenide and new LIs you are using that. Okay, at the last, characteristics. One of the question from the previous year question paper, where you got the maximum power, in case of solar energy. That power, hence power output of the cell must be operated at the knee point of the curve. So then we will get the maximum. So this is one of the previous question. So consider the characteristics of incident light, 100 megawatt per centimeter. See here, this is 100 megawatt per centimeter. This particular characteristics, like whenever it is short circuited both the end terminals, that means here, see here, the characteristics is like that. Whenever you are short circuit both, okay, then you will get the short circuit current. Okay, that current will get 50 milliamp, for example. Okay, now second case, whenever it is open circuited, so this particular thing, this particular diagram, whenever it is open circuited, then you will get some voltage, right? Open circuit voltage. In that open circuit, what about the current? 0. So that means this is the point we have, this particular point, voltage is only present, current is equal to 0. In between this particular curve is drawn. Okay, whenever it reach the knee point, that is a maximum power output will be generated. This is a knee point. That's what here characteristics of a solar cell. Okay, and then we can uses. Solar cell are being used in board satellites like ISRO, some manufacturing satellites also we are using solar panel, solar cell, and rechargeable their batteries. Okay, like the solar cell can be used in the domestic purposes as well as industry. They construct the solar panels to generate energy, like agriculture they use the solar plates or solar energy. Like this is about the solar cell. Okay, at this we end this particular chapter. Thank you.